Self-shielded flux cord welding is a wire welding process in which a continuous hollow wire electrode is fed through the welding gun into the weld joint. Self-shielded flux cord welding differs from MIG welding in that it doesn't require an external shielding gas in order to protect the weld pool from contamination. Therefore, it does not encounter the weld problems that can occur when MIG welding outside with strong winds blowing the shielding gas away. The flux contained in the electrode also allows the process to be more forgiving of base metal that is somewhat rusty, dirty, or otherwise contaminated. Flux cord welding does produce a slag that sits on top of the finished weld and must be chipped off, similar to stick welding. Be sure to clean the portion of the base metal or workbench to which the ground clamp will be attached. Poor contact with the ground clamp will create resistance in the welding circuit and could result in poor weld quality. For general-purpose mild steel applications, a flux cord wire with the E71T11 classification can be used in any position, is available in a wide range of sizes, and provides excellent welding characteristics for both thin and thicker material. As for wire diameter, 0.9mm diameter makes for a good all-round choice for welding a wide range of metal thicknesses. For welding thicker material at higher total heat levels, use 1.2mm wire if it's within your welder's output range. How much voltage and amperage a weld requires depends on steel thicknesses, joint configuration, welding position, and wire diameter. Reference charts are available at welding.com.au. These charts should be considered rough guides from which you can fine-tune your final parameters based on a couple of test welds. Stick out is the length of unmelted electrode extending from the contact tip, and it does not include arc length. Generally, flux cord welding requires a stick out of around 15 to 25mm. This is important as you need to preheat the flux inside the wire. Travel angle is defined as the angle relative to the gun in a perpendicular position within the plane of the weld joint. Normal welding conditions in all positions call for a travel angle of 5 to 15 degrees. Travel angles beyond 20 to 25 degrees can lead to more spatter, less penetration, and general arc instability.